very much. It's really nice to be here. I've met some of you before, and it's always a pleasure to come here to Quebec and see what you're doing and talking with you. It's hard to follow up after a great speaker like Kevin, but I'll try my best. So over the years, I'm based out of the Niagara Peninsula, and the Niagara Peninsula in Ontario has gone through a huge transition over the last 30 years. We've gone from a lot of Labrusca grapes and hybrids to more and more vinifera. And so with that, cold hardiness has become a main priority because we want to make sure that we're optimizing the hardiness in our vines and also having good protection strategies as well. And by the combination of understanding cold hardiness and having some practical solutions to help the vines get through the winter. And it's been work done by my colleague Kevin and others. And a lot of work being done, across North America in recent years. Cold hardiness research, there was a bunch done in the 80s and the 90s, and then it kind of, a little bit less across North America, but now there's more and more cold hardiness research being done in North America, and it's becoming more of a priority in BC, Washington State, Ohio, Colorado, Idaho. These are all regions where we're focusing a lot on cold hardiness. And then you're probably familiar with the one project with now I can't forget the name. With Tim Martinson was the lead, Kevin? The Northern Grapes Project. And so that's been a huge initiative as well. So I want to talk a little bit about what we know. The more we know, the less we know. As Kevin said. And the more research I'm doing with cold tolerance and cold hardiness, the less I realize I actually know. But I'll tell you what I do know and some of your experiences. So without being said, we've done a lot of cold hardiness research because of our freeze injury is one of the greatest threats to grape and tender fruit crops. We need a better understanding of the factors involved with cold hardiness, and I'll talk about some of the factors that impact cold tolerance. And then also optimizing cold tolerance in plants and understanding the processes of what's happening and how we can help the vine. Be good to your vines, right? So they'd be good to you, and try to help them get through these tough, difficult periods. And with climate change, we are seeing huge impacts, and we're going to see larger impacts in terms of grapevine cold tolerance. It's going to impact grapes in the growing season and maturity, but we're already seeing the effects of climate change in Europe. If you look at what's happened in Northern Europe, and particularly in some of the northern regions in France, like Champagne, Alsace, Burgundy, parts of Italy, they all had frost damage this year, or hail damage, or a combination of both. And these are probably due to climatic changes. And so, particularly during the deacclimation period, which I'll talk about, climate change is going to have a huge impact on grape production. So, we talked a little bit about buds earlier, and which one's the pointer? Grapevines are unique in the sense they have a compound bud. So there's 3 buds within the grape. There's a primary bud, secondary bud, tertiary bud. And this is a dead primary bud. So this is where most of your shoot growth and your fruiting potential is from your primary bud. In this case, the bud has been injured due to freeze injury. You can see it's brown, necrotic, where this is just a very healthy grapevine compound bud. Why is that important? This is a bud just prior to bud break. And we took a cross-section of the bud and put it under a microscope. And as you can see here, that this is a fully developed bud, and you can actually see the apical meristem. You can see the first leaf, you can see, or second leaves, and you can see the inflorescence. So these are already predetermined in the plant. That dormant bud, those dormant buds already on those vines out there, have next year's fruiting potential already. It's predetermined. So all of your fruit potential is in those dormant buds. So we depend on those buds. And that's why when I talk about the future, we look at bud, cold tolerance, and so on, because and survival, because that's what's really, really important to us and in terms of production and for growth and sustainability of that vine. These are some of the consequences. This was an early spring frost in 2012, and this was an old Labrusca vine at the grape station in Vineland, where Helen Fisher was out of. And we had some early bud break in Labrusca and some hybrid varieties, and they were frozen out after a spring frost. This is when you have some severe damage, and you have the green tissue here, whereas this one you have the phloem and xylem. The whole bud is, or sorry, the whole cane has been damaged. And this is what you see in the most extreme events. This was a very bad winter. After a very bad winter, and you could see a lot of winter injury there. Primarily, you don't have really any growth up top. You have some suckering in some cases. Basically, the entire vine is dead. There isn't any renewals.
Excuse me, the picture before, if we cut the canes in the field, can we see that? Should we see that in the field, like exactly when you cut the...
You can cut in the field. The problem is, and I'm going to talk about that I think this afternoon, so I'm going to talk about, like Kevin and I can probably talk about that maybe even together a little bit in terms of doing our sampling and looking at winter injury. The problem doing in the field is that the tissue has to warm up and oxidize, for one. So if it's just after a cold event and you go and cut plant tissue, if it hasn't warmed up, you're not it hasn't oxidized, and you won't see where the dead tissue actually is. It'll all look green.
But at the end of the winter, when you prune, if it's like
yes,
the picture on your left,
yes,
it's probably okay.
Yeah, and so when you're doing your pruning cuts, sometimes when you're cutting back on the cane, you look at the tissue and you can see that it's brown or it's gray, and then you know it's dead. And you will have some natural dieback anyways, and I'll talk a little bit about that. But you can see some of that in the field, while you're pruning, or you could you can do some cuts yourself in the field as well. But what we do is we'll do some destructive sampling, and we'll actually cut canes or trunks to get an indication of what kind of damage we had. And as Kevin mentioned yesterday with the Riesling vines, where he did the cross sections to look at that dead tissue within the trunks, and it's quite obvious when you do see some damage. This is a cane sample. So if you can have some phloem damage in the cane tissue, and it won't impact the vine, it can withstand some phloem damage, and it will recover. The problem is when you have over 50% phloem injury, and it can become cumulative over time, where you're getting more and more cane or trunk damage, or cordon damage or trunk damage, then it can have an impact on the plant. But normally speaking, you can have quite a bit of phloem damage and the plant can recover. However, you usually have a ton of bud damage if you have a lot of phloem damage, because buds, which I'll show you in a couple slides, are more sensitive to the cold than your phloem tissue. Does that make sense? Usually when we see a lot of bud damage, if it's after a really bad winter and growers are approaching Kevin and myself, we'll generally say if there's over 50% bud damage, you're probably going to have a lot of phloem damage as well, and to be prepared to replace parts of your vine. But I'll get into that. I don't want to get too ahead of myself.
But just maybe a simple question: as the phloem and xylem is the same
level of tolerance?
Yeah.
No. And I'll get to that in a second. I just flipped a couple slides because this is just an example of some trunk splitting. And I want to get into the main part of the talk, and then things will hopefully start flowing a bit better for everybody. So in terms of cold tolerance or cold hardiness, it's the ability of the plant tissue to survive freezing temperature stresses. It's very complex, and there's a lot of factors involved, and a lot of them, at the end of the day, it comes down to genetics and the environment. And the genetics plays a huge role, and it basically limits the inherent potential of the plant and how much cold it can tolerate. It's just like, me being my size, I'm better at football than I am being a horse jockey or a gymnast. I'm predisposed to different injuries because of my height, back problems and things like that. And so it's just like the plants have evolved to where they were evolved and where they originated. They've learned to, not learn, but they've adapted to their conditions. Now with us, grapes have been cultivated for thousands of years, and we've moved the plant material around. So these plants haven't fully adapted to where we're growing them. And vinifera is a perfect example in terms of they're only hardy to, in the -20s, whereas our native vines, Vitis riparia, labrusca, so on, they can tolerate a lot colder temperatures down to -40s. And so when we're breeding grapes, those that are breeding grapes, and you look at the Frontenac Marquette and others, they've taken some of that grapevine material from Vitis riparia, and that's where the inherent cold tolerance comes from. It's from those species of grapes. So like I said, it's highly influenced by the environment, and I'm going to show you some diagrams and some graphs and data about how our growing seasons alone, just within one region, can impact cold tolerance, and it's also a highly dynamic condition. So it's not like as soon as the vines lose their leaves, they're at their maximum hardiness and they stay that way. It's a very dynamic condition, and it goes through a period of acclimation, maximum cold tolerance, and then we lose cold tolerance during the deacclimation period until we start growth after bud break. Now when we talk about different environmental conditions, this is a pretty popular diagram here, basically looking at of grapevines cold tolerance throughout dormancy in a colder region versus a warmer region. They just do not acclimate to the same extent, but there is a limit in terms of how cold tolerant these plants will get, and that's determined by their genetics. So it doesn't matter what you do, you're not going to get them to withstand colder temperatures than they can possibly achieve. So just in terms of general principles, the way that the grapevine buds withstand freezing is through a process of supercooling, by which the liquid remains in a fluid liquid state below normal freezing temperatures. Now during a freezing event, in terms of what happens within the cell, is that water outside of the cell will freeze in the intercellular spaces, the walls, the epiplaste, they'll be freezing. That'll occur in those regions. It's not a lethal freeze, and what happens is the osmotic potential within the cell decreases, and this pulls water out of the cell from inside the cell and increases the concentration of the solutes within the cell. So what this basically does is it concentrates those solutes, which it improves the freezing tolerance within the cell. More water is then removed from the cell, and this continues to lower the freezing point within the cell. And then after the freezing event, once the ice nucleation I'm trying to think of the word, stops. Like once the ice stops within the extracellular spaces, then the water just diffuses back. Now, one of the problems in terms of cell death is that there's so much water removed from within the cell that causes physical stress within the cell itself, and basically it's a lot of stress on that cell. Think of ice wine fermentation, and there's a lot of stress on your yeast cells. For those of you who understand about osmotic stress, it causes a lot of stress on the cell, and it's the same thing within plant cells. And so what happens is they do have mechanisms to cope with this, and I'll talk a little bit about that. But the problems with some of the cell death is dehydration, and this leads to either a change in pH. We have higher solute concentration, so the pH within the cell will actually change, and it doesn't take much for a pH change for a cell to die. And same thing with us, with animal cells, no different. This is more of a chronic cell death. So this happens in more chronic conditions, generally speaking, when it's been a long, cold event, and we get this dying of tissue, cells and tissue over a period of time. And we probably had more of this chronic type of damage during the polar vortex in 2013, 14, 14, 15, we had long periods of freeze just above some of our critical lethal temperatures. And over time, the plant just becomes so dehydrated in the cell, we get some chronic death. Then there's the intracellular freezing, or you have a catastrophic event, and this is your acute stress, where the water freezes from the cell, just physical damage, proteins are denatured, it's just massive structural damage. It's just like when you have water, a bottle of water in your car in the winter, and it freezes and it just breaks everything. And you end up with broken glass and plastic. That's basically what's happening within the cell. And that's the challenge. With the dehydration, after some of those cold winters, a lot of us tried to mimic that and do some experiments, and we could not figure out how long it would take. But with the intracellular freezing, as Kevin mentioned, it's like that once you hit the critical stage. And it's almost like, you know, in the winter when it's a cold morning and you put on your windshield fluid and you just, as soon as it hits the windshield, that's kind of what's like the cell. Like, it's just massive freeze, and it's over. So when we talk about recommendations to the growers about mitigating freeze injury, we always say you have to be ahead of the game, because once that event happens, it's too late. It doesn't matter what you do. So in terms of cold sensitivities, I mentioned this a little bit. Buds and roots are your most sensitive. I mean, roots are very, very sensitive. And in some regions, especially some of the arid areas of the West Coast, Washington State, and even in BC, they can get some root injury. They've had some rootstock trials in BC, and they lost a lot of certain rootstocks because they end up freezing. So roots are very susceptible. We usually don't have problems with our roots freezing, generally speaking, in the East Coast. But we really, that's just why a lot of our work that we do, we look at the buds, because they're easy to measure in terms of grapevines, because they super cool, and that they're also the most sensitive. So they're a really good indicator. Kevin?
Where they had root damage was the drier the soil,
Yeah.
the greater the depth of penetration of the cold temperature, the more likelihood of root injury.
Yeah.
And that was happening in BC. Their soils were dry, and the cold their frost layer got very, very low in the soil profile.
Especially their sandier soils. I should have touched on that. Thanks, Kevin. Because that's the reason why they're more susceptible. And in Washington and some other places, what they'll do is when they have deficit irrigation for when they grow their grapes, and doesn't matter. They have different regimes for sparkling wine production, for red wine production, but it doesn't matter what they do for deficit irrigation. They always add some water post-harvest, and that's to charge the soils a bit and to help mitigate any potential root injury. They also want to get a little bit of extra growth and try to keep the canopy a little bit healthier, but I'll talk a little bit about that in terms of post-harvest effects in winter hardiness.
Is it possible to have a trunk damage and no bud damage? Yes.
Because as Kevin mentioned yesterday, you can have the death from 1,000 nicks. And so from cumulative winter injury from previous years, the vine gets through, it's doing well or well enough, you think everything is fine, but it's an old trunk and it has gone through, let's say 3 or 4 hard winters, maybe even 2 hard winters, and therefore you get a crop load on it in the season or something and it will collapse. Mm-hmm. So we provide, a lot of the advice that we provide to the industry after a cold event is replace your trunks. Like bring up some suckers, because your trunk has probably sustained at least 1 year of cold injury, but maybe more. It's best practices to basically keep your vineyard healthy and going. So you can have this hidden, it's almost like what I say is an individual who appears totally healthy. They go about their daily life, but meanwhile they have blockages in some of their major arteries, and then they go for a run and they have succumbed to cardiac arrest. It's a similar thing with the plant. There's blockages and damage within the vascular structure that you don't really see. There are some signs, just like that person maybe had a little bit of chest pain, one day, but the vines don't talk. And so you have to look for some symptoms and look at the history of that plant, what it's gone through, and then that help you determine if it may have some trunk damage. You can also do some destructive analysis too, and if you think there's some damage, is actually cut some canes, or cut some trunks or cordons and have a look. So like I said, cold hardiness is a dynamic condition. We have this period of acclimation, maximum hardiness in the coldest period of the winter, and then this period of deacclimation where we're losing cold tolerance. This is a typical smoothed out, nice clean graph. However, in reality, there can be some ups and downs, particularly in these times of year. And I'll show you some actual graphs. Now, the first thing to talk about is dormancy, and I'm going to talk about winter dormancy, which is suspension of visible growth. There's also some dormancy that occurs during the season. And can anyone think of where parodormancy, it's called, kicks in, where there's an example of that?
Sorry, what's the question?
So there's some dormancy that occurs during the growing season as well. What remains dormant during the season? Yes. So the latent bud or the dormant bud. So it's developed, as Kevin mentioned, during that, closer to bloom, and that in June, we're getting the bud initiation and so on, but it doesn't break bud. It's some dormancy. That bud remains dormant. And then it continues to remain dormant. The first stage of dormancy is endodormancy, and it's basically inhibition of growth. And this one it's regulated by physiological factors. There's a lot of things that need to happen within the plant for it to break endodormancy. It's under hormonal control, and no matter what you do, if you take those vines, bring them inside, warm them up, they will not break bud. The only way to break bud is if you would apply some kind of plant growth regulator on that material to help break that bud. But in terms of winter dormancy, it's induced by those endogenous signals, hormonal signals, and so on, as well as the environment. So low temperatures, photoperiod, and so on. Now, that's one of the most misunderstood areas of plants is like when I took a graduate level plant physiology course, it was called there was a topic called the secret life of plants. And it's basically circadian rhythms. Right now we're having shorter days, mornings are dark, we don't want to get out of bed. Our bodies are on that internal clock. Well, plants have some kind of internal clock that we don't really know about. A lot of it is due to sunlight. And so these photoperiods in lower temperatures trigger responses in the plant. And one of them is the initiation of dormancy and acclimation, which I'll talk about. Once the plant reaches and can break endodormancy, it goes into a period of ecodormancy. And ecodormancy is basically, it's a result of unfavorable conditions. Some type of stress will keep that plant dormant. It could be drought, but in most cases, and especially in terms of for what we're dealing with cold tolerance and so on, and in terms of this talk, it's cold temperatures that keep the plant dormant. So when we have those cold periods, it's keeping the plant dormant, and it doesn't want to break bud and then get froze out. I mean, the plant doesn't think, as Kevin said, but it's all these environmental cues are what's keeping that plant dormant. So plants, perennial woody plants, have chilling requirements. So they have to reach a certain number of chilling hours for them to break that dormancy. And they cannot break dormancy without going through a number of chilling hours. We don't have problems achieving the chilling requirements for our woody perennials, at least that we grow commercially in Canada. Some regions in the Middle East and so on, they have to go through spray some plant growth regulators for them to break dormancy. However, for us, we achieve our chilling requirements usually by the end of December. Certain varieties have different chilling requirements and different chilling units as well. So and I'll talk about that when I'm comparing vinifera hardiness to hybrid hardiness. And it's really interesting how the plants differ in terms of deacclimation and so on, in terms of how they can break dormancy. This is a very complex sequence of events that occurs for acclimation. It takes a lot longer for a plant to acclimate than for it to deacclimate. But ultimately what it's doing is it's going from a cold tender to a cold hardy state. There are so many factors involved with this. If you are a molecular biologist or a biochemist, physiologist, the area that you work on, you're going to say that's the most important factor in terms of why the plants are more cold tolerant. In reality, it's kind of like an electric circuit or a series of bulbs. And if you cut one, it's probably not going to be effective downstream. There are a lot of factors involved with why plants are cold tolerant. And that's why, just like disease resistance, you cannot replace one gene in a plant and it's going to be a lot more cold tolerant or disease resistant. Very, very complex. A lot going on. There's changes in gene expression. And one of my colleagues at the University of Guelph has identified, her and some other researchers throughout North America and other regions have found these different cold hardiness genes. And a lot of these genes are related to water regulation during the growing season, but then they play another role during dormancy. Because if you think about it, tolerating the cold is about managing water and keeping water from freezing. Well, during the growing season, there's a lot of things happening in the plant to keep them from suffering from drought stress. And just like with cold tolerance, there's some varieties that are better surviving the drought than others. And it's the same thing with cold tolerance. And some of these, like the ice gene, is an important factor for cold tolerance. I'm not going to get into the molecular biology so much, nor I want to touch on the chemistry, but I still won't go into too much detail with these. But there's chemical changes within the plant, and Kevin's talked already about some carbohydrates and movement of carbohydrates within the plant. There's proteins involved as well. There's also compositional and physical changes, and one of the typical physical changes that you could see in a plant, and you could tell during acclimation, is period. So lignification, the bark on the plant, on the shoots. If you go out to the field and you start to see periderm formation, you could say the plants are starting to harden off and they're getting ready for winter. That's a physical change that the plant is undergoing, and you can actually see that. And obviously, just like everything in plant growth, hormones are involved. And one of the major hormones involved is abscisic acid, or ABA. And it's a very important plant hormone in terms of, again, water regulation and dormancy. And during dormancy, it will increase in the buds and the nodes, particularly during acclimation. And then it will induce a lot of these different compounds, particularly some of the proteins that are involved in cold tolerance. So in terms of vinifera, we have two stages of acclimation. The first is induced by your cool but above freezing temperatures, and this is starting at like raisin period. So when there's leaves on the vine, the plant's getting ready, and it's shifting its period from growth and vegetative in reproductive growth into it wants to get ready for winter and start to acclimate. So cool temperatures and shorter days trigger it. And then the second stage is below freezing temperatures. With Riparia, for example, we can have a lot of acclimation, and will acclimate deeper just with the cool days and the shorter days. And it just the genetics of that species. Then what happens is we reach our maximum cold hardness period during the coldest months. And from a lot of the research that's been done, it's actually when the plants are ecodormant. So they reach their maximum hardness usually in January, February, and at that point the plants aren't endodormant, they're ecodormant. So it's a really interesting concept. That's where actually they're the most cold tolerant. Now in terms of acclimation, it can be accumulative. So it can stop, and then it can progress again. it can be reversed, and this is all on temperature fluctuations. One example that we saw in recent years was, it was around Christmas. I think we were talking about this the other night. It was Christmas a couple years back, and it was almost like 20 degrees. It was in the teens. And a lot of people were really concerned about the grapevines and what happened with those vines. And during that warmer period, the vines didn't necessarily gain hardiness. They maybe lost a little bit of tolerance, but they were able to gain it right back once it got cold again later in the year. If that would have happened later in the season during deacclimation, it could have been a lot. The vines would have lost cold tolerance and probably wouldn't have gained much back if it would have gotten cold again, and it would have left them more susceptible.
Because they were in
But since they were endodormant still, they were okay.
So is there any evidence for, like in Ontario, you guys plant vinifera, or I guess they're not planted on rootstocks?
They're all
Or
planted.
are they
They're all
planted?
grafted.
They're all grafted. So is there any evidence for better interactions between frost acclimatation for when they're planted on rootstocks and not? Does that because you're talking about how riparian, for example, has a different effect than just on vinifera. Is there a different end, like for the hormone production, or?
We're studying rootstocks and tolerance right now, cold tolerance right now, and we're actually looking at different clonal combinations and rootstock combinations, but we're just at the infancy of that work. There are direct effects of rootstock, as you know, but there's there's indirect effects of rootstock. So improving vigor or that type of thing can impact. It's an indirect relationship that can improve, that can impact hardiness. But there can be some direct effects, but we haven't done a lot of work. Stan Howell did some research at Michigan State where we actually did some inverse grafting, and like 3309, for example, is a pretty hardy rootstock. And so far with our research that we're doing, 3309 seems to be a pretty good rootstock. Riparian, to be honest, hasn't shown to be very good for us. But there's other problems with riparian rootstock in Ontario.
Well, we have the same thing.
The part though is that if you have a rootstock that's hardy to minus 30, and you graft it onto a variety that's only hardy to minus 22, you're not going to make that variety hardier.
Oh, yeah.
Right? There's no transferal of the hardiness from the rootstock. It's just the rootstock can survive better, but how it impacts on the growth of the cultivar is the thing. Because people were thinking, oh, I got a hardy rootstock and I graft on top, I'm going to get a hardier vine. No, you still have a hardy rootstock, you have a cultivar that's only so hardy.
Exactly.
You don't change the genetics.
Yeah. Otherwise, that Merlot that you have grafted on that rootstock wouldn't be Merlot anymore. It's true to type. The one thing I can say though about rootstocks and getting back to Washington and those dry soils is that own-rooted vines didn't do as well in terms of root survival because the vinifera roots are more sensitive to cold than, let's say, 3309 or any rootstock, most rootstocks that don't have vinifera parentage. So I don't have to go too quick or too much detail about this, but basically, because I've already talked about this, but just after leaf fall, I mean, we have the periderm formation on the plants. There's a mobilization of nutrients, carbohydrates to the reserves. So the perennial organs of the vine, the trunks, cordons, canes, and roots. And that's happening, as Kevin mentioned, soon after veraison. So I mean, the plant is not, I mean, it doesn't want to necessarily make good fruit for us, for wine production. Its main objective is to survive the winter. And so there is that mobilization of carbohydrates and other things to the permanent structures of the plant. But it's starting to get rid of water throughout the plant, and eventually the buds are isolated from the cane and the vascular tissues. Basically, there's a barrier zone that occurs, and it basically creates plugs to keep water from moving into the bud and so on. We're starting to get more concentration of sugars and other organic solutes within the cells, in the buds and so on. Within the buds. And then our cells are dehydrating, like I mentioned, and the membranes are starting to stabilize. So the membrane stabilization is really important because, like I said, it's like a balloon, and if it doesn't have some more fluidity in it, it'll just break when it freezes, or when there's some stress. So there's a lot of compounds involved with membrane stabilization, and that's why, like I said, it's not just, some people that work on some of the carbohydrates, complex carbohydrates, say, well, they're the most important factor in hardiness, and other ones say, well, it's the proteins. Other ones say it's proline in terms of stabilizing proteins and so on. Well, it's really everything that's combined that's helping with cold tolerance. And basically, the colder the temperature gets, the more that the water is being redistributed within the tissues, and there's more and more desiccation. And basically trying to get rid of any free water, so they're binding to these chiroprotectants and so on. So just like that berry development slide that Kevin had, this is one that's probably used almost in every cold hardiness talk. It was from Cornell originally. And this basically just talks about, it's just a visual graph in cartoon about periodorm development and bud acclimation. So in early September, you're getting your acclimation from the base of the shoot to the tip. And so when you start seeing some periodorm formation, the plant will have some ability to supercool. And then it's acclimating further down that tip, late September, early October. And then ultimately, you get to a point where this whole area of the cane, for example, can tolerate a lot more cold, can have more deep supercooling. Whereas in this, the apical part of the tip or the apical part of the shoot hasn't acclimated well. And when we go to the field today, we can have a look and you could see how acclimation has occurred down the shoot.
Yeah.
And so you always end up with some dieback.
So, do you recommend to do some cane pruning in autumn?
Free pruning, like
Because here we have a producer that's doing some cane pruning in autumn in order to have less job in spring.
Okay.
But I saw this in our project that when the buds it's
Further.
further, so you have more cooling damage on these buds. So it's why we don't cane pruning in autumn here. We're doing this in spring for us. But do you recommend to do this?
Well, if you're doing autumn pruning, are there even leaves on the vines?
no.
No.
So it won't have any impact then.
Okay.
But
Yeah, go ahead.
in Ontario, what some will do, they would never do a finish pruning in the fall.
No.
No.
But what they can do is remove the most distal brush, take most of the more difficult wood, and leave a
Yeah.
large number of
Yeah.
canes with 15 buds,
Yeah.
knowing
Yeah.
that you're not going to keep from
It's
positions
down the
15
cane.
outwards. Yes, you can do that, and a lot of people in Ontario start in November
Yeah.
because Labruscas and hybrids, that's okay. If there's dieback, there may be only dieback, but only a very small amount, because but to follow what you're saying, do your rough pruning to get the big work out of the way, and then in the spring, it's much easier to do your finish. Yeah, you can do it, but we don't do any finish pruning. It's all just basically the biggest time.
And if you have only half of your shoot that's has one leaf with wooden leaf, the buds that's at the bottom of the shoots are okay and they can survive for
Probably not. They're probably not as strong as these ones would be here.
Yeah.
As you could see the progression. If it's only half the shoot has lignified, these buds here probably aren't going to be as good as the basal buds in this situation where you've had periodorm formation right from the base to the tip. And it's important to, you'll get through the first part of winter and not see any damage, but eventually, once you get a really cold night, you will see the damage on the apical part of the tip.
Question. In some place, vigne don't leave the leaves and stay green until mid-November. do you suggest to apply some fungus or like copper or like sulfur to accelerate to increase the falling of leaves?
Well, I haven't done any experiments with any copper or anything like that. I mean, Kevin, I'll let him speak on sprays. The only post-harvest sprays I've looked at have been some plant growth regulators, and I'll talk a little bit about that. But I'll let Kevin talk about, I'll let him comment about copper.
We've used Bordeaux spray post-harvest, but where we used it was in a block that had a tendency to grow very late. Now the rationale, we thought we were getting better winter hardiness, and because we would get the leaf drop, lignification, but then what it came back to, we were at a place where they were propagating, and the late spray actually allowed the wood to be in better quality when they went to do propagation versus whole survival of the winter. They had a dilemma that they were bringing in overwintering spores of powdery mildew, botrytis, and other things, and the copper was acting almost like a disinfectant on the surface of the wood. It wasn't changing when, after that, and I'm talking 20 years after we first started doing it, and we could put them in the freezers, we did not see a change in the buds hardiness level. So would I go out if I had leaves in late November, green ones at the tips, and I've got a meter of growth or more? No, I'm not going out to do it. It doesn't make any difference. The buds you are retaining are already at their point. There's certain varieties that will just leave green leaves, but no, there's been no improvement of a very late copper application in terms of overall hardiness.
So you can see here though that there's a lot of variation in terms of bud tolerant, cold tolerance. This is we cut multiple canes, looked at bud position, and then just looked at the overall cold tolerance in terms of LT50, at which the temperature which 50% of the buds would be predicted to be killed. And you can see there can be a lot of variation across the cane or the shoot, but generally speaking, your buds at the further end can be a lot less cold tolerant than at the base of the shoot. And this comes into play with how we test cold tolerance. We make sure we're consistent with where we sample. For our regional sampling, for example, we're going to sample the buds that are going to be retained by the growers the next year in terms of pruning. Some of our research trials, we try to target in this area so we can run more samples. The key is to be consistent, but they never all freeze at the same time. There's a lot of variability with that canopy, right? You see that all the time. And so each bud is not developing the same way and hardening off the same way. One bud could have a leaf shading it so it doesn't have the same sun exposure. There could be mechanical damage on the cane, and it could, just from that, can impact the development of the bud or the hardiness of the bud, and so on and so forth. So there's a lot of factors. Even having a cluster adjacent to that bud might have put some extra carbohydrate stress or less carbohydrate accumulation on that bud compared. There could be many factors that can impact that. So when we look at hardiness, we look at large numbers of buds.
Because when we examine the bud before pruning, do we know if we had hardening on a certain length on a shoot? Can we know that those first buds are super cooling?
These buds are always going to be in better shape than these buds.
Yeah.
But the damage can be variable in the field. And I was going to talk about this afternoon. Depending on the type of freeze event that you have, you can have different damage. Even though these buds are less cold tolerant, let's say here, if we have a radiation freeze and all that cold air settles, you can have a layer of stratification and everything's dead below that point because they're vertically shoot positioned. Does that make sense? So sometimes the buds might be more cold tolerant, but they may have been exposed to lower temperatures. It's
because they are lower.
Because they're lower.
Okay, yeah.
And that cold air settles. Does that make sense? So it's really hard to say that those buds were more or less cold tolerant. Generally speaking, these ones are definitely going to be less cold tolerant. So you can expect more dieback on those. And generally speaking, if it's been a tough winter, we will recommend spur pruning versus cane pruning if there's a significant damage. But then there's the economics of spur pruning and all the issues that come with that. So we made those recommendations. Then at the end of the day, the growers are like, why did we do that? We might as well have just left extra canes and just see what we had. Because the amount of work with spur pruning, they can't do all the shoot thinning within the period of time in the spring when it's so busy with so many other things. They just don't have the time, the labor to do it. So there's logistics that come into play too, but I'm getting off topic.
I wonder if any of this can be related to acroteny as well. Is there a way that, like, you know, distal canes are more fruitful than ones closer to trunk? And does that have any influence on how bud distribution is, and whether or not the ones that are more distal are less hardy than the ones that are closer to the actual cane?
Yeah,
does that have any effect, like the way that they're?
Yeah.
Is it because there's less reserves within the bud, or or that they're less adapted to, or that they produce more during the season, so they're less adapted to hardiness at the end of the season?
That's a tough one. I mean, in terms of cane, you're talking about cane position within.
Yeah, because I mean,
like, yeah.
Distal canes are more fruitful than the ones that are closer to the trunk. So, you know, within vine balance, we're looking at how to figure out, you know, to make sure that the ones that are close to the trunk are going to be just as fruitful as the ones at the very end. Hormones are going to be distributed more towards distal end of the cane, of the cane. I'm wondering if that's also an influence on the cane. Hormones are going to be more distributed to the top, and is that, you know, why maybe we see that bud 15 is going to be less hardy than bud number 1, for example? Is that?
Yeah, it's a lot comes into play. I mean, in terms of just auxins and what have you, it's working against you in terms of acclimating. But in the most distal shoot is usually the one that's very vigorous as well, and usually with a little bit more bulbwood. So there's a lot of variation within the vine. And sun exposure has a big role. I mean,
Well, we found on shoots, like in terms of looking at a shoot, bud positions 3 through 7 are roughly the most fruitful buds that you've got on a shoot.
3 through 7?
From bud 3 to bud 7
Okay.
on a cane.
So you
When you take that shoot and lay it down to become a cane, bud 3 to bud 7 are often more fruitful than bud 1 or 2 or bud 8, 9, 10, 11.
So you consider bud 1 size the base of bud?
No, well, it's not your ring, but it's the first Winkler's thumb. Put the thumb down and it's the first bud above your thumb. That's bud number 1.
Okay, yeah, and it's usually less.
It is less fruitful. That one and the next one are often less fruitful than the remaining buds if you let them go. But they are still fruitful. Doesn't mean that they're not fruitful.
But
often they'll only produce a primary cluster, possibly a second. They won't give you a tertiary cluster or whatever.
yeah. And I'll build on that a little bit too in terms of hardiness. So you were asking about fruitful buds in hardiness. What we find is generally that the base bud in like the Winkler thumb rule, those in bud 2 are more variable in terms of their cold tolerance. And what a lot of our research trials we're sampling buds 3 to 7. 3, 4, 5. Yeah, 3 to 7. And that's what we use for our vine replicates because we feel that those are the most reliable buds with less variation than buds 1 and 2. So that's to build on Kevin's answer, yeah. And then within the canopy, it can be quite variable depending on even shoot positioning, that type of thing. It can be quite variable within a canopy.
But sorry, it's like this because of the genetics, not because of the cold.
The hardiness.
Yes.
Yes.
Yeah.
Yes.
Okay. And if we do spur pruning, would it be better to keep 3 buds?
If you're doing hybrids, most hybrids are running 5 to 7 buds on a spur, and then selecting from there. Like I'm talking about if you were going to do a high wire drop. If you're doing a low wire, they're going at least 3 to 4 buds.
Okay, and then remove the first.
Yep. Then that's the cost is the follow up to thin out the non-desirable shoots.
Yeah, but it's costly to do this.
But if you're in a vertical shoot position system, and it's something again, we've gone through, the fellows are going, and growers are going through, we have mechanical pre-pruners, which are the spinning blades. They look like pie plates, and they drive right down the row and buzz everything off. And then the person following up is just doing quick cuts. I have growers that are probably 30% of their vineyards every year. That's the way they do it to get ahead of the game.
Yeah,
Because then they're not pulling brush.
They pre-prune the top, but not to remove the first two buds that break, like,
They wait until they see what, yeah, but that's,
but they're doing by hand?
oh yeah, they have to. There's no machine that'll, that's that smart.
Uh-huh.
Or the reverse side is we're that
Refined.
stupid to do it by hand.
Okay.
Exactly.
But that's really, but with hybrids, the other part to remember is hybrids generally are very fruitful on buds 1, 2, 3, like more so than vinifera.
Okay, yeah.
You should, yeah.
So you can go to your, 2 to 3 buds. On
Okay.
vinifera, they'll look at spacing of spurs to get them apart and look at 2 buds or 3 buds. But again, they're looking at very controlled crop yield. But on hybrids, a 2-bud spur, I'm not going to get overly concerned about it. But you want to have a lot of them because it's vigorous.
Mm.
So if you don't have enough buds per vine, enough spurs, you can be in a problem as well.
Mm.
And over time you get antlers, as we call it, because your spur keeps moving. It gets higher and higher and higher. You gotta get-
Mm. Okay.
So I just want to get moving a little bit in terms of getting past acclimation and getting to some more of the practical applications that we've seen and put things into more real world situations in terms of just theory. But in terms of plants, they have a lot of cryoprotectants that they use to help depress freezing and so on. And I've talked a little bit about some of these already. So one of the big things that Kevin talked about was mobilization of carbohydrates. And during acclimation, starches are converted to sugars and then to complex sugars like the RFO or the raffinose family oligosaccharides. So like stachyose, raffinose, and so on. And they are kind of like cold hardiness signatures in terms of these accumulate at periods of a more maximum cold tolerance. There's a lot of proteins involved. These kind of act as antifreeze. Dehydrins are one. We're looking at dehydrins right now. For those of you who know Andréane, one of my grad students, that's what she's measuring right now in different grapevine material. Amino acids, like proline is an important one for stabilizing some of these membranes. And there's also lipid composition changes, like I mentioned, to help with fluidity and so on of the cells. So these are all different types of antifreeze and mechanisms that plants and animals use as well. So frogs, for example, they have ability to use all these different cryoprotectants to survive over the winter as well. They bury under the dirt and the mud and so on, but they have to have a mechanism to withstand freezing temperatures, just like other amphibians and cold-blooded creatures. So it's pretty interesting. So deacclimation is a loss of deacclimated hardiness. It's essentially the reversal of acclimation. And this occurs once we start getting warmer temperature conditions. And like I said, it's more of a reciprocal of acclimation. Rising temperatures will induce reversal of starches to sugars. These complex sugars like the raffinose and so on, they're being converted to simple sugars. Carbohydrates are also being metabolized. And this is part of the reason why during acclimation, a lot of energy is used for the plant to acclimate. A lot of resources are used up. Deacclimation, they're now metabolizing some of those carbohydrates. And that's why they can't go backwards very well once they start losing cold tolerance. So we're also getting there's more of these antifreeze proteins and antifreeze compounds. They are declining within the tissues, and we're starting to get more rehydration. So it's really the reversal of the acclimation process. And this is very rapid. It can be very rapid. I could show you some graphs in a little bit. There's acclimation, it's taking weeks to months to do. And deacclimation, depending on when you have those large temperature rises in temperature, it can be from a couple days to a couple weeks. So if it's very late during dormancy and you get very warm temperatures, the plant will move quite quickly. If it's earlier on during dormancy and the temperatures are just slightly above normal, let's say there's what's normal, but it could be deacclimation can be a little bit slower. So acclimation, like I said, depends on a large amount of energy. I mean, there's changes in structure, there's physical changes like periodic formation and so on and so forth. Whereas deacclimation is basically just fueled by the metabolism of carbohydrates and proteins that were synthesized during the acclimation period. And this is one of the areas that researchers are really interested right now. Us cold hardiness researchers are really interested in deacclimation and how climate change can impact what we might see in the future. And the other thing that comes with reacclimation is this whole thing called reacclimation. Not reanimation like Frankenstein, but it's about gaining back hardiness. And we do see, if you would sample a grapevine every day or every couple days, you would see the bounce in the hardiness, not just a smooth transition. You have a general trend of acclimation, but there are periods where it may drop, it may remain stable, it may come back up and then reacclimate, and so on. So this is a really interesting concept, but like I said, the longer it is during dormancy, the later in dormancy, the harder it will be to reacclimate. Earlier in the season, plants can reacclimate a bit better. In certain varieties, species do better than others. And I'll show you some cultivar examples in a bit. And this is one of probably the greatest risk of freeze injury due to climate change is this warming during eco-dormancy and how periods of warm weather, so we have a very warm, let's say a January thaw, and we have very warm temperatures followed by a big cold front that comes in. And whereas we can quickly grab a jacket if it gets cold and go outside, the plant takes a little bit longer to get their layers on, let's say, to acclimate to the cold, especially later in the winter. So these ups and downs, fluctuations in weather and temperature specifically, can have devastating consequences for survival. And do not think that, and you've probably experienced this, that with Frontenac or some of the very cold tolerant varieties that they're immune and they're going to get through winters just as easy as other hybrids or vinifera even. Because I'll show you some data about how these different varieties respond to warm winters. And it's really, really interesting. Look at the seasonal impacts that we can have in a given region. So this is Kevin and it's our data, Kevin in KCMS and Brock. We collaborate on our cold hardiness model, regional sampling that we do. And this is just one variety at one location over like an 8-year period, really. And you could see that with every given year, we can have different rates of acclimation. Maximum hardiness can change within a variety. And we can have variation of 2 to 3 degrees or more difference in terms of our maximum hardiness. But then during deacclimation, it's really, it can be highly variable, and it's all based on those late season, late winter, spring temperatures. This year here was 2011-12, where we had extremely warm temperatures in March, and we lost about 10 degrees of hardiness in a 2-week period. We went from being hardy about -18 in a lot of our varieties to hardy -6. So we, through our hardiness modeling program, monitoring program, we informed the industry, hey, we have to do something about this and modify the temperatures at which your wind machines are going to start, because you cannot go by a calendar date to see how cold tolerant the plants are. If you look at March 30th, on any given year, look at the differences we can have. This year, we lost 90% of the apple production in Ontario. I think you were hit by the same in Quebec. And we had a lot of loss in tender fruit. The tender fruit industry decided, hey, you guys were doing this work with grapes, got together with Kevin at KCMS and through a partnership, started a tender fruit monitoring program. So now there's a program that tracks the tolerance and cold tolerance in a lot of tender fruit as well as grape.
So it's all automated. You know that the the bud hardiness is at this level at this
At this
point.
time.
So you check the weather forecast and say you should start the wind machine because it will be lower than the bud
Exactly.
hardiness.
So this is like an outreach service program that we've provided to the industry, and it's also a great research tool for us as well. But because half of our industry is protected with wind machines, the growers now have a tool that they have at their disposal that if temperatures drop below these critical values, they can turn on their machines and hopefully mitigate those temperature effects. And so what the growers do is they get this information. When new data is posted, it gets sent to their email, and I'll have some slides on this later. And then the growers can set their wind machines on auto start or what have you at temperatures just above those critical values. Now this is LT50 data, but they would set it to the LT10 data, so at damage with 10% of the buds would occur. And so at this period of time in this year, they were already about -6, and there's still about at least 6 weeks left probably of frost risk. And they end up running the machines quite a few occasions in between that time. And we were able to save the grape crop that year, and then it ended up being one of our best vintages ever, 2012. It was a great vintage. And so without that, we would have lost those potential buds. So it's been a really powerful tool, but through this database, like look at the information that we get in terms of looking at how one variety responds at one location. And it differs by variety, it differs by location, and so on and so forth.
So you take sample twice a week or?
For this program, we're taking samples every 3 weeks during acclimation and start of maximum hardness, and then it's every other week.
Okay.
But we're sampling continuously. It's hard to, at one site in one variety,
So
we're sampling on that schedule, but there's continuous sampling every day.
Okay.
So we always have new data,
Yeah,
like
yeah.
worth every day.
Okay.
We have, there's a network of inversion of sensors out in the fields that growers have themselves, but there's also a weather innovation network in Ontario. The Grape Growers of Ontario have a fee that they pay every year so that growers have access and we have access to their data. And there's some inversion towers there too to help measure the strength of inversions. But a lot of the large growers have that information themselves as well because it can be site specific. So we have it on a regional scale that we can get a sense, but there's also on the grower level. And that's what we're kind of moving to more and more. And that's what we're moving forward with. We do cold hardness modeling. We want to get down to the site specific, just on the temperatures and then based on a subset of actual measured hardiness data. Part of the program, as much as knowing when to turn them on, is trying to save the growers from using them when it's not needed. So Kevin has called it recreational wind machine use, where you run it just to make you feel good, even though there's no need. And it just all it does is make your neighbors angry, and it costs you a lot of money in wear and tear on the machines. So we've saved the industry. We've done some economic analysis at $2 million a year just in fuel savings through this program, because during acclimation, we could see how the vines are acclimating, so they turn them on only when they need to, and the same during deacclimation. And then they know maximum hardness. Okay, because Chardonnay, for example, or I use Sauvignon Blanc as even a better example. Some years it could be really not very cold tolerant, and in other years we found it hardened off well. There wasn't a lot of late season growth that you can get in that type of variety, and it was quite hardy one winter. And so the growers who are growing those varieties can dial in for the varieties they grow and the locations. So, and that's where I'm getting to now, is like different varieties. No cultivars are created equal. We know how they're so different in so many respects, and they're also different in terms of their cold tolerance. Just like they grow differently, the fruit matures at different rates, they have different levels of drought tolerance, so on and so forth, their season requirements. It also impacts how cold tolerant they get. And this is just the same thing, different varieties at one location, and you can just see the level of cold tolerance that some of these varieties have. Merlot is generally one of our most tender varieties, and you can see at this point of time where we had minimum temperatures that dropped to -20, you could see we had damage likely in Merlot Cabernet Sauvignon, Pinot Noir, and then in Sauvignon Blanc, I should say. And then some of our, your more cold tolerant vinifera, like Cabernet Franc and Chardonnay, likely didn't sustain damage during that period of time. So it just shows the fluctuation. They have different rates of acclimation, different levels of maximum cold tolerance, and they can deacclimate at different rates. And I want to get to that point next. This is just a cut down. Chardonnay is a variety that deacclimates at an earlier rate. It's one of our vinifera that break bud earliest. And this is just an example of just how we can have different rates of acclimation, maximum cold tolerance, and deacclimation. And these are just different examples of how years can vary. Again, this is at 11, 12, and these are some of our colder winters where they just they stay dormant for a longer period of time. So we can actually, with the data, we can actually kind of predict when bud break, like what our bud break is going to look like too, to some extent. I'm not going to get into detail here, but we have a lot of the same equipment that we use to measure cold tolerance. We're hoping to help you out and have some collaborative research with Carolyn doing cold tolerance measurements here. And this is just an example of just the schematics of what we do. But if you're interested, I could talk about that. But in the interest of time, I think I'm going to just talk about how we have cultivar differences in cold tolerance. Well, again, it comes down to genetics. The vinifera originated in Europe, Middle East. So they have different levels of cold tolerance than some of the French hybrids that had some North American material. And so there's a lot of variation within vinifera. Syrah, for example, originated in like Iran, Iraq, somewhere in the Middle East, whereas Riesling would have been Western Europe. So that you could see that just where they evolved, they have different levels of cold tolerance. And the same thing. So just looking at different vinifera varieties first. Riesling generally is a little bit more cold tolerant than Chardonnay, Pinot Noir, but given years, there can be some fluctuation. Of all different Bordeaux varieties, Merlot is one of the most cold sensitive ones. Petit Verdot, Cab Franc are one of the more cold tolerant ones. A lot of variation, and these, are all from the same region of France, but they have different levels of cold tolerance. Looking at a whole bunch of different varieties, you have Italian varieties that are generally more cold tolerant or less cold tolerant. Same with some Rhone varieties, Spanish varieties, and then another Bordeaux Semillon is also quite tender. But a variety like Auxerrois is more cold tolerant. Then moving into, and you're looking at these temperatures, and they're like low -20s for a lot of the LT50. Moving forward, look at the LT50s. This was during a cold year in Ontario of some of the hybrid varieties. So Baco Noir, for example, cold tolerance to -30 or so. Frontenac Marquette in mid-30s. And Vidal has been really interesting over the last number of years. And crop level has had a big impact on it, especially overcrop vines. We had a couple years where they were young Vidal vines. They had over 10, I think they were 3-year-old Vidal vines. They had over 10 metric tons per acre on them. And all the shoots were stunted like this. And it was only hardy to like -16. It was less cold tolerant than vinifera. It got beat up really bad that year, as bad as vinifera. And other growers, we saw the same thing up on the escarpment, right, Kevin? After the polar vortex, a whole bunch of Vidal got like wiped out. It was really bad, a lot of injury. But it had to do with just abusing the vine. As Andy's quote, "Be good to your vines, they'll be good to you." The problem is Ontario, one thing is some hybrid vines are really abused. They're like beating children. Like they're just so overcropped and overworked. They're like slaves. And the grower they don't care about the lifespan of the vineyard. They're going to make their money in a shorter period of time. They're not looking at longevity in these vineyards, and it does show with some of the cold tolerance that you see. And then coming back after some cold, you might get away with it if it's a mild winter, but if it's a cold winter, you're going to pay for your sins if you want to look at it that way.
is there a certain amount of yield overcrop that will influence the rusticity?
You know, I'm going to show some data if I can get to it in terms of some of the research we've done looking at crop loads, or crop levels I should say, in vinifera at least. The vine will tell you if it's overcropped. From the research that we've done, if you look at the vine and it looks balanced or close to being balanced, and you get good fruit maturity, you can expect that the vine will have good cold tolerance. If the vine looks out of balance, you have a lot of green shoots, it's still growing late in the season, and you know you've overcropped it. The fruit quality never reached good fruit quality. You really struggled with that, and you know it doesn't, probably not due to a virus or something. You can expect it's going to have less cold tolerance. Just do that. You can tell on the vine if it's overcropped by some of the symptoms that Kevin talked about yesterday in vigor issues. If you have vigor issues, overcropping issues, and the vine is out of balance, you're probably going to have, you can expect some reduction in cold tolerance. But it's forgiving. There is no absolute number. It's just like, what is a perfectly balanced vine? It's really hard to put a number to it. It's an overall picture. Yeah.
In many cases, poor fruit maturity will tell you that the plant is not as hardy going into winter.
Yeah.
I mean, taste the fruit, the texture of the fruit. If the fruit's not balanced, doesn't taste right, that plant has an issue.
So over the years, we're growing some of the Minnesota varieties in Ontario. And we started testing them back in, I think, 2012 or 11. One of our larger growers he planted a big field of Marquette, and he also planted some of Helen Fisher's numbered hybrids. And so we agreed to kind of help out Helen and test some of these different varieties and compare them to some of these Minnesota varieties. And what we're finding was, geez, they're not as hardy as we thought. And like, we're seeing that they're young vines, and we're, okay, maybe they're young vines. And you know, I talked to Peter Hempstead many times, and he's like, oh no, they're hardy to like closer to -40 and all these things. And I just want to show you a case study of some of the data we have from these varieties. So in this chart, I've compared it to Riesling. So Riesling is one of our hardier vinifera varieties. You know, generally speaking, the LT50s will get close to -25. And this was a cold year. This was a very cold winter that we had. We had consistently cold temperatures. It was our coldest February. I think this was the year we had the coldest February on record. And we're getting responses from Frontenac, Marquette, and so on, were maximum hardiness, you know, closer to the mid-30s, -30s. But even with colder temperatures, just the days getting longer alone, they were deacclimating. And you could see in a hardy vinifera, these varieties are about the same level of hardiness during deacclimation. So I want you to be aware of this with these varieties. They're not bulletproof. Now watch this. This was during a warm winter. These varieties acclimated a bit better. They got deeper into acclimation, but come the end of December, they're already starting to deacclimate a bit after that warm weather that we had at Christmas. They had already reached they've already hit their endodormancy period, and they started deacclimating. They only reached a hardiness of -25, and then later in the winter, I mean, Marquette is less cold tolerant than Chardonnay. And this was really interesting to us. I mean, Frontenac changed its hardness a bit better. And then this is during a 3-year period. That's the first graph that I showed you. This is the second year in terms of that really warm winter where like a lot of periods of time, Marquette is same as vinifera for cold tolerance. And then this last year, you could see, again, Frontenac performed a bit better, but Marquette, it's deacclimating quite early. And we've seen some similar responses with some of Helen's varieties. And so Helen and I have done a lot of back and forth, and a lot of it has to do with the longer days. It's just a cue because of that riparia in their background, it's a cue for them to start deacclimating. They want to get off to an early start. They have shorter season varieties. And they probably have less, the deacclimation rates are different with these varieties. Just like how Chardonnay and Cabernet Sauvignon, for example, can be much different in terms of how they deacclimate, or Riesling. It's usually slower to deacclimate. And so it's something to be aware of. And when Tim Martinson from Cornell University, he gave a talk last year in Ontario about the Northern Grapes Project. And he had mentioned that during some of their warm winters, they lost all of their Marquette in some of their regions. In Frontenac, in Michigan, as well as New York. And it's because they're well adapted to areas that are cold and stay cold. But if you have warming periods during the winter, they can be problematic. So I know you have some of these, and you may have seen similar things here. But I just wanted to show you some data that we collected in Ontario to help validate some of the things you're probably seeing in the field. And one of the things I would like to add, I didn't mention this before and I should have, but during deacclimation, when the water is moving a lot through the plant and you're having rates of deacclimation and buds are only hardy to -6, -4, it's not just the buds you really have to be worried about that time. I mean, you have to worry about the other parts of the plant become very susceptible. So again, you can get cane, trunk, cordon damage at that point in time. And that's a lot what happened when they lost the Marquette and Frontenac in New York and Michigan was trunk damage. Because they were deacclimating at more than, they had deacclimated quite a bit at that point in time, and there was flow through the plant. They had more damage because of that. That deacclimation, you can get really whacked. In late in deacclimation with a big freeze because the plugs have been dissolved in the plant and there's active movement. Once that starts occurring, the plant's very susceptible. It's like being out in the woods and not having your coat on and you get a freeze. So it can be devastating, and that's what when we look at the buds, and every year pretty much when we look at the hardiness of the buds. Kevin, myself, and Ryan, who's at KCMS as well, we all get together and we usually write a report a message to the industry to always remind them that, yeah, this is how hardy the buds are, but you have to be mindful of other things as well. And growers they're through education and so on, they understand that, and they will run their wind machines more often, even though the bud damage might not be the same, the level of the risk for buds might be the same, but they might turn the machines on even a little bit earlier just because they're worried about their trunks. So it's really, really interesting. And after testing so many varieties, I'm not so set to say, just because it's vinifera, it's going to respond this way, and just how it might be a later mature in the growing season, like Petit Verdot, but it's actually more cold tolerant. It's kind of weird. It's not everything responds the way you think it would. And perhaps it's just the environment it's grown in. Ontario's different we can get different responses than the West Coast or other regions. And we found that when we compare data and we talk to each other. It's very interesting. I think what we see in Ontario will be more similar to what you would see here in Quebec. But it's really, really interesting in terms of how plants respond. And you change their environment that they're native to. It's really, really interesting. But like I said, the more you think you know, the more you don't know.
Wow.
And that's where the next thing we're looking at now is within a species, within a variety, looking at different clones. I'm fortunate to have some blocks that are already planted, where they've planted all different clones in one block. So these are all right next to each other. And these are 12 different Chardonnay clones. And you can see that we have some significant differences during the acclimation period. No significant differences during maximum hardiness, but in reality, some of those clones are 2 or 3 degrees less cold tolerant than others. But deacclimation, this is what we've seen in a lot of our studies. Temperature just drives it more than anything else. And within a variety, very similar responses. And same thing, these are different. This is looking at 2 different varieties, but within the varieties, different clones. So 2 different Riesling clones here, and then this is one of our more tender varieties, Sauvignon Blanc. And we could see some differences during dormancy with these different varieties. But I did want to present some research that we did in terms of looking at some viticulture practices and how it could potentially impact cold hardiness. Has been some discussion today even about time after harvest and leaf fall and the amount of time you need between the two. And we had similar questions too in our industry about ice wine production, for example, and is that going to impact hardiness and that type of thing. So what we did was we did a study looking at the impact of crop level and harvest date. We looked at vinifera only, and we looked at Riesling in terms of our harvest date is ice wine for ice wine production. All the rest were done at commercial harvest and then 3 weeks later for our late harvest. So we wanted to see if we had an impact on crop level, on harvest date. And then the other variable that we looked at were 2 cropping levels. We looked at 1 cluster per shoot that some premium producers or premium blocks are doing. They're dropping their crop down to 1. And then looking at what we considered a full crop with 2 clusters per shoot. We didn't have a treatment looking at like totally overcropping because we figured that would be number one for the blocks we were using that was hard to do because they were fairly low vigorous sites, and also we wanted to have more commercial representation. We figured that a grower wasn't going to just totally overcrop their vines, but in hindsight we probably could have had that treatment as well. But anyways, we wanted to look at normal production levels and then with vinifera. So this was just an example in our Merlot block, 2 clusters per shoot, 1 cluster per shoot, so on. So we did this study over 3 to 4 years with tender variety like Sauvignon Blanc and Merlot, and then some of our core varieties that are used for ice wine, Riesling, Cab Franc, as well as Chardonnay and Pinot Noir. Now, there's a lot of data that we collected. I'm just going to get right to the point and show you how it impacted hardiness for some varieties, if it did. Now, I got a question for everybody in the room. After you pick the grapes, what happens to the canopy usually? Within like a 1 to 2 week period, what do you start seeing happening? The leaves start shutting down, right? So it's kind of an interesting phenomena. And so we were like, okay, our hypothesis was more that crop level was going to have an impact, harvest date, not so much. And based on some previous research, we figured that it would impact acclimation, but we weren't sure necessarily about maximum hardiness. What did our results show? And then I'm going to give you general trends here from what we found. Now, I'm not going to look at every single variety, but I'm going to show you some information. So just looking at Sauvignon Blanc, and this was in a cooler, wetter year. Sauvignon Blanc is a variety that is known to have very late season growth. It doesn't shut down well in the fall period. And what we did find was that having the 2 clusters, having a heavier crop level on the plant, delayed acclimation early on. But once that fruit was harvested, it acclimated very quickly. And by December, January, we were at the same level of hardiness. Only time we saw any differences with crop level was early on in acclimation. The vines catch up. It slows it down, and if you track maturity, if you track fruit maturity, it's a nice correlation generally with wood maturity. So it's similar to what Kevin was talking about earlier. So harvest date, ultimately, what we found with all of our studies, generally did not impact anything at all. Riesling wasn't really impacted by harvest date at all, crop level more so. The bigger the crop you had on the vine, the slower the acclimation rate was. Generally speaking, no differences later in the year. And Tony Wolfe has shown this work in Virginia when he did some studies looking at crop levels and hardiness. Ahmed Dami did some work in Ohio State, and they found that crop levels didn't impact hardiness in Ohio at all with hybrids like Vidal, unless it was overcropped. So overcropped vines were vines that, in terms of Ohio State, they were looking at Vidal that, I can't remember the number, but they were probably like 8 to 10 tons an acre, I think.
So 20 per...
I think they were in that level that they were considered, but that was for that block, right? It could be, you might not be overcropped if you have big vines, and your Vidal vines can handle those types of cropping levels.
And do you think like in our condition, vines can manage overcrop. That's same as in the south, or
Well, overcropping it means the vine's out of balance. I think your vines, as Kevin mentioned, have larger capacity, so they could probably handle a larger crop. But overcropping is a relative term. It's not an absolute number. It's more of having too much fruit more fruit than that vine can handle and be in balance. So an overcrop vine would be one that was struggling to reach maturity, short shoots, those types of things, showing stress early in the season, that type of thing. In terms of an absolute number, I mean, if you look at crop load, where you're looking at the ratio of pruning weights to or yields to pruning weights, I mean, you'd be looking at above 10 type of thing in terms of crop load.
Because our winter may arrive earlier and maybe colder, do you think it would be the same?
Yeah, I would say yes. I really would, unless it's a really early frost. But I think that if you have, I mean, the leaf fall on this block was, we were picking grapes after the frost on in this occasion. I don't, unless it's a really short season, and your cultivar is way out of balance in terms of your growing season, way out of whack, then I think you're probably okay.
Yeah, but
with these cropping levels.
In 2011, and if you do it year after year, you have studied that?
Yeah, year after year. The year after this, there was no difference.
No?
And
so that's what I
the 2012 year was one of our best vintages on record. Didn't matter about cropping level that year at all. The whole graph for 2012 looked like this. They were all within really tight parameters to each other, really tight values to each other, the whole year. We didn't find any differences at all, except for one cultivar, and I'll get to that soon. But we found consistent results. In a cooler, wetter year, it had more of an impact in acclimation, but in a very good year, if you had good fruit maturity, you have good hardiness. So it comes down to that whole issue of vine balance. It really does. And so this is some data, but you don't really need to be taking any data to understand that. This was to basically, we had a lot of people in our industry that were concerned, and so we did the research. But in theory, I mean, from previous research and just from what you know from a plant physiology standpoint, what Kevin was talking about, the vine's already mobilizing carbohydrates and acclimating. If you think of a vine in the wild, they want some of their fruit distributed by birds and so on, but their wild vines are hanging crop in the woods and so on throughout winter. The birds are feeding on it throughout the winter months when they can actually see it. But the only thing that we do as humans cultivating growing these grapes is that we're manipulating that crop level by pruning, by our trellising system, by maximizing the amount of fruit that we can get on those vines. Because naturally, in a natural situation, these vines aren't going to be very fruitful. But it's through our cultivation of grapes that we force the grapes to produce more than they should, or they truly want to. So as long as you're within a certain parameter and you have this vine balance, you're going to be okay. You might have some decreases in some years with certain varieties, but ultimately, as long as it's not a super cold winter, you're probably going to be okay. Now there's always if we had a really early hard freeze, these vines could have sustained more damage. But generally speaking, I mean, by January, the coldest months, they're pretty much the same.
Yeah.
I mean, it's not, and every situation can be different. I mean, in terms of this is a general trend. I'll show you Pinot Noir, which is the only one that's different.
Yeah, my question is, you study overcropping, but many of our producers are undercropping.
Yeah.
I mean, they have really low yield, and the grape are mature but could be better, I guess. And so the vine are not well balanced,
Okay.
but and they do not survive well, and it's the circle.
This Pinot Noir are very low yields for this Pinot. I mean, it was between 1 to 2 kilos of vine for the 2 treatments. So they're both very low yields. Crop level, or probably crop loads, were probably probably about 4. Probably a crop load of 4, and they in this case, what we found with Pinot Noir, doesn't matter the year, that the 2 clusters per shoot definitely had a little bit less cold tolerance than the other treatments, regardless of harvest date. Harvest date didn't really have a difference at all, but actually had some difference in terms of harvest date, but generally speaking, crop level had more of an impact. Now, undercropping is an issue for sure. And if you're having severe undercropping, you can end up with a vigor problem and also have poor acclimation. My colleagues out in Summerlin, BC, have been doing similar studies to this, and they found actually that the 1 cluster per shoot has reduced hardiness because the vines are undercropped.
Could you repeat?
They're finding that out in the West Coast, that by having 1 cluster per shoot, their crop loads are too low, and they're finding that they had some reduced hardiness in some cases. So it can be region specific, but on the East Coast, this is fairly similar to what other places have found, Ohio and Virginia. In terms of generally speaking, the larger crops can delay acclimation, but generally speaking, you don't have much differences during maximum hardiness. The only one that we found, like I said, was Pinot Noir. That seemed to be susceptible. But we all know, and growers know too, that Pinot is the one variety that it's weird with its yields. Pinot. It's amazing wine, but growing it sucks.
You said you had less rusticity with low crop. Is it because
the vine is unbalanced?
It's unbalanced. It's because of the shade, because of
Yeah, but generally it doesn't have enough fruit to hold back the vigor, like Kevin was talking about in the vineyard yesterday. So you can have a low crop if you have small vines. You can have a smaller crop. If you have a huge vine and you don't put any crop on it, it's just going to continue to grow. And that late season growth is what you don't want. Just like what Kevin was saying yesterday about hedging and having all these extra growth late in the season, and the fruit it's wasting those carbohydrates. It's not going to the fruit. You want that energy to go to the fruit, and you want it to go to the reserves to the perennial wood, the perennial organs. You don't want it going into growth, vegetative state at that point. Like in the annual growth of grapevines, Kevin had at the end. He had end of the summer, August. You want your growth to stop, and when you don't have a crop on there, and you have lots of nutrients, lots of water, and you have a vigor issue, the vine won't shut down well, and you'll have poor acclimation because it's going the wrong way in terms of in terms of its growth habits that you want at that time of year. So that's where vine balance. Basically, what I'm trying to say here is it comes down to vine balance in terms of hardiness.
Yeah.
It really does. Yeah. But Pinot Noir is a bit of an exception. It's pretty wonky, and we found this year after year. Just in terms, and then we'd find this as well with Pinot Noir. It was the only variety, like Cabernet Franc and Merlot, we didn't see differences in terms of coloring, but on the same date, we would find that the fruit maturity was a bit ahead with the lower crop Pinot Noir. And then these were just some of the examples of our number of clusters, our yields per treatment for vine and so on, pruning weights and what have you. And then this was an interesting one because it just demonstrated we had some differences in bud survival with Merlot at the end of the year. And I just have a visual representation here of this was a heavier Merlot crop with a late harvest. And this is a very susceptible variety for us in terms of winter injury. And if you look at these vines here, they had slight they had some winter injury, then they're also slower to bud out. But you could tell that they have quite a bit of injury, that these probably will collapse, and they did, based on the number of suckers you see at the bottom here. It's a sure sign that you probably have some winter injury when you have little growth up top and lots of suckering at the bottom. But then these were the other vines that were a lighter crop with an earlier harvest, and they seem to get through the winter a bit better. And it just, when you have a really tough year, very small differences can make a little bit of a difference. And we found that with our Merlot trials. But generally speaking, we didn't see a lot of differences. But I thought that was kind of a cool, that's an overcrop vine, for example. Like compared to the vine next to, like there's some issues going on with this vine, but then look at the crop level and it cannot sustain any growth. I think I was with Kevin on when we saw this together. This is Syrah, and some of these, there's a picture of me next to one of these vines, and the shoots are generally higher than I am. But for some reason, something was wrong with this vine, but it was carrying the same crop level as all the rest. And that vine, I'm sure, didn't get through the winter. Just completely overcropped. So I mean, that's an extreme of an overcropped vine. So in terms of just viticulture, management, in terms of just general relationships with cold tolerance, I mean, it goes without saying that if it's a healthier plant, it's going to get through the winter better. Just like us, if we're battling with a cold or virus or what have you, we could be more susceptible, or we have other health issues, we could be more susceptible to other things when we're under some stress. And it's no difference with vines, whether it's, if you have a vine that's defoliated early in the season because of downy mildew, for example, your canopy is not healthy and you're not getting good photosynthesis within the plant, then you're going to have poor fruit quality and ultimately poor maturity. Things like viruses, we're trying to understand more about how that impacts hardiness. Drought conditions, again, where you're having stunted growth, defoliation, those types of stresses can impact hardiness. Soil issues, again, impacting growth when you have compaction and so on. And then what we've talked about already, things like previous winter injury, crown gall, these types of things where there's damage internally within the trunk and within the permanent structures. These can all impact hardiness, but that goes without saying. I mean, a healthy vine is a good vine. This is a classic example of wet feet. So if a vine is sitting in standing water, what we see a lot of times is poor growth, and then this is what we commonly see in the fall: leaf drop and very poor acclimation. And in the wet areas, it's a double whammy usually, because a lot of times they're sitting in wet feet, they have poor growth, and then in the winter there also can be cold pockets in those sections if they're low-lying areas, and they're vines that are poorly acclimated plus colder temperatures in the winter, not a good combination. So that's just why we do all drainage tiles in our vineyards, and more people are moving more and more into every row as opposed to even every other row. And I'm Kevin, Helen. You guys have done a lot of work over the years in showing how drainage tiles can improve consistency in the vineyards, production, and the other caveat is just getting through the winter better as well. This is just some work from my former technician when she did her master's with Andy Reynolds, and just looking at water status. And what they found was that having a little bit of water stress improved bud hardiness. So with slight stress, and it just comes down to, I did my PhD looking at water stress and water status and Riesling wine quality and so on and so forth. And it really comes down to just kind of like almost like a rootstock effect. There's the indirect effect of vine water status, and it can help mitigate vigor, improve microclimate within the canopy by basically having a more manageable canopy when you have some mild water deficits. There's been lots of research done worldwide about how mild water deficits improve wine quality. And I mean, we're talking about Kees van Leeuwen from University of Bordeaux, and it's all about water and water status and terroir when it comes down to it. The physical properties of the soil and how some water status, or how water status really impacts the final wine quality. And it's due to direct as well as indirect factors.
So So on the slide, what we see on the left is the water status.
Yes. No, this is the. Sorry, this is the. The water status here. I got them mixed up. Sorry, water status here, and bud hardiness. So we find is that with the worst stress, we could have lower bud hardiness.
Okay.
So the optimal range was in the mild water status category. It's hard to see because of the values. So if you look at the colors, it doesn't correspond perfectly to the values. So just take my word for it. Famous last words.
The red are the lower level?
Yeah.
Okay, the lower level are red and
Yeah.
the higher level are blue.
Yeah.
And so the water status when there is more water.
When there's a lot of water, the bud hardiness was lower. Yes. And again, that relates a lot to not having, the vine has lots of water, lots of growth, and that's season long. Yeah, season long.
When you have drought, it's also impacting the bud hardness.
When you
have drought.
Oh, drought. Yes. And it's the same deal. Not last year, in 2016, we had a very, very dry summer. And the vines and it came down again to vine balance, but drought impacted the vine's balance. So we had a good sized crop because it was a year after we had a couple bad winters. And then we didn't have large canopies because we had a lot of winter injury and so on. The vines have been low cropping. So we were in a situation where vines could have a decent crop on them, and they did. And then we had a very, very dry summer. So in some cases we had vines that were under stress and they had a decent crop level on them. The other thing were very young vines didn't have a lot of roots, a lot of root capacity yet. And so those were the vines that, I think, Kevin, you probably tested a lot of these same vines probably with clients and so on. But the younger vines that had some drought stress did have reduced hardiness. Some of the older vines that had and that were balanced and got through and had some irrigation perhaps, but they were a lot better during the growing season compared to the younger ones or the stressed ones. And that goes with the old age model of old vines make better wines. I think there is some truth to it in the sense that those older vines they're more in balance and they're well established. They can get through the stressful periods more and make a more consistent product. That's kind of what we found in a lot of our terroir research that we've done over the years, was that more consistency. But the young vines and the vines that are out of whack due to winter injury or so on, those are the ones that when you have a stressful condition, like I said, in terms of health and balance, those are the ones, as soon as you add a stress factor to them, like drought or anything, you can reduce hardiness or quality, fruit quality as well. They're always linked. I really think that's, good fruit maturity or good wood maturity equals good fruit maturity or vice versa, whichever way you want to look at it. So that's where drought can have a big impact. And I talked a little about this last year, and Mark Matthews, Dr. Matthews he's retired now, but he's at University of Davis. He's done a lot of work with water relations, berry development, and so on. And we talked a lot about this type of thing, water status and hardiness. And we're both talking about the same thing. It's water. I mean, it's just like with berry maturity, it's impacting hardiness the exact same way. And so there's a lot of similarities with that. And so again, mild water deficits are good. Too much water, not enough water, is going to have negative impacts on the vine, both in the fruit and both in maturation. Does that make sense?
One thing that we've observed is that a wet fall has far more impact on vine hardiness than a dry fall. Okay, if you've had a normal growing season, but you have a drier than usual fall, your vines actually will survive winter to a better degree than if you have a normal growing season and then a wet fall, because the vines don't seem to acclimate water relations inside, they just stay wet too long. And there seems to be some influence. So just keep that in the back of your mind that if you've had drought from the beginning of the year, that's one thing. But if you have a dry fall and good ripening weather, your wood actually matures very, very well. But if you have it wet, it doesn't seem to want to mature.
Yeah, and I'll go back to this one because Kevin's exactly right. And like, if you see here, 2009-10, I mean, it was pretty wet most of the year, but it was a slower year to acclimate. 2013-14 was another one, slower acclimation, not as hardy in the winter. And these are the types of things that we see. But the drier years, we seem to have, in a drier fall, it does seem to shut the vine down more. Just anecdotally, this past year we had a really wet summer, just like you guys. But September we got really good weather. And we were out doing actually point quadrat analysis with some of our leaf removal trials this year. And we were out there at Verizon and we couldn't believe, like, oh man, these vines haven't hardened off very, very well at all at this point. In a dry year, like last year, we had période formation to the tips of the vines probably by the end of August. And we're like, oh, this is going to be bad news maybe for acclimation and so on. And then we had this beautiful September and things have hardened off quite well at home. And you have good période formation out there in the vineyards right now. So that's a good sign. And you could see it right there in the vines. Just that what you're kind of getting into. Once we start testing, we get into the nitty gritty. But generally speaking, you can get a lot of information. Like right here, looking at that, that's not well acclimated. That's going to die back. First big freeze, that's done. And so we see that in vineyards though. Like we had, and it goes back again to different species. At the grape station, there are a lot of different Labrusca varieties. Own-rooted Labrusca. Well, 2012 vintage when it's hot and dry, those Labrusca had shoots that looked like that and had no leaves. And Helen Fisher's like, well, this is typical Labrusca in a drought year. They're like, and they didn't come back. They died over the winter because they just had so much stress on them that they couldn't handle it. So you get a lot of information just by looking at the quality of the wood in the fall. And you'll see the bullwood out there in the vineyards. It's not going to have as much période information on it and things like that. A lot of persistent laterals. We'll go and look at some vines when we're out in the field. We could look at that. The last thing I just want to talk about here, just some plant growth regulator sprays that we've been working with vines to try to help them acclimate. So we did some work with, or I talked earlier about how abscisic acid is involved with a lot of the acclimation processes and how it's involved with water regulation and so on in the plant. And so in the last number of years, we've been looking at foliar applications post-harvest, looking at natural ABA, which is commercially available, as well as these new analogs, which are it's synthetic ABA that mimics natural ABA. And what's really special about these compounds is that they catabolize more slowly in the tissue. Natural ABA, it's really hard to get into the plant, number one, and then it's gone right away within the plant. And so it doesn't remain biologically active because it's being catabolized to its catabolites. And these aren't biologically active. So with these analogs, they were from the synthesized through Dr. Sue Abrams, who's at the plant, or she was at the Plant Biotechnology Institute out of Saskatoon from NRC, and now she's at University of Saskatchewan. And she's a hormone specialist and chemist. And so she provided us with some of these analogs to test with grapevines. And they were used to help improve color and improve dormancy in seeds. Canola is a big thing, right, in terms of in the prairies, and looking at how these growth regulators can be used. So a whole bunch of us who are doing cold harness research got a hold of these compounds. Valent Biosciences contacted us as well. And they said, hey, can you do an experiment where we spray these on the vines, and we're going to have a lot of data from different regions all at the same time, same cultivar. So we worked with Pat Bowen out of Summerland, Marcus Keller out of Washington State, Ahmed Dami was involved with one project out of Ohio, and some others from Idaho and Colorado. So we had many different growing regions, and we want to look at how these can impact the vines. Well, this was with just natural ABA, and it found that improved hardiness. This is just an example of my data from Ontario, and what we found was improved hardiness in October. This was middle of October basically, but after that we found no significant differences throughout the year, and this is with the natural ABA. Looking at the this is just, I took it directly from the publication, so it's not blown up very well, so it's hard to see. But with the analogs, we found an improved hardiness in terms of an improved acclimation early on. This was with Merlot. It did not, and this is what point I want to make, it did not enhance the maximum hardiness of that vine. Under our conditions in Ontario, I would say generally speaking, our vines reach their maximum genetic potential in most years. And it doesn't matter if you spray anything on them or do anything to them, they're still not going to get below a certain point. You're not going to all of a sudden magically turn, Merlot, that's hardy, negative to generally between -18, -20, let's say, in the winter, let's say -20, you're not going to all of a sudden make it as hardy as Frontenac just by doing a couple things in the vineyard. It's genetically, that's what it's going to be. However, the one cool thing about these analogs is they're able to maintain dormancy within the plant. So this was 12-13, but there's data on 2011-12 as well, and we had very similar results. And it helps maintain dormancy within the vines. And when we have warming periods, it keeps the vines dormant, and it reduces the rate of deacclimation. In 2011-12, with the one concentration of the analogs, we delayed bud break in Merlot by an entire week compared to the other treatments. There are some studies that have been done with the same analogs, and they delayed bud break for like 2-3 weeks, depending on the conditions. But in a more normal year, what's interesting is that bud break occurred pretty much at the same time. So it seems to really help maintain dormancy in extreme situations. So what we're doing now is we're trying some new compounds this year. They're also the same type of analogs, the 8' acetylene abscisic acid, but we are going to do more and more chemical analysis within the plant. So we want to track ABA concentrations throughout dormancy. We want to see how it's impacting and how is it maintaining dormancy. Is it extending the endodormant period, so the vines are, as Kevin said, early to bed, early to rise type of thing? Is it impacting that aspect, or is it something further downstream? That's what we're trying to look at now. So anyways, I wanted to point that out because everyone's always asking, is there something you could spray in the vine to make them more hardy? But what I think is really interesting with this is to help mitigate the impacts of deacclimation, which I think are going to be more of a greater risk worldwide. And looking at some quick data that I'll show you in a second. I just want to leave it on that note before going outside. But this is from Marcus out in Washington, these analogs. This is what's kind of neat too. Like how I said, how it delayed bud break in extreme situations, but in a normal year, the bud break occurred at the same time. It delayed a lot. So not only this year did it delay bud break, but then we had delays in many different stages of growth up to when the berries were around pea size. And then the vines caught up and it was normal crop, no differences in fruit composition or anything like that. So it was kind of a really interesting thing how it delayed early season growth, but didn't, at the end of the day, didn't have any impacts later in the season.
And when did you spray?
Post-harvest. So they would have been sprayed for Merlot. We would have been putting our spray applications on between the beginning of October to middle of October, depending on the region.
On leaves?
On leaves. Well, the leaves are still functional. We got, so as soon as the grapes came off, we were on there in backpack sprayers and we sprayed the vines.
So you don't have any commercial producers that use that technique yet?
No, it's not commercially available. The only one that's commercially available in the United States is Valent Bioscience has a form of ABA, the natural ABA, but we didn't get these results with. So perfect example is, this is, these are the analogs. We had some delay actually with the natural ABA, but it was at such a high concentration that we didn't feel it worked very well. But most of these are the analogs here. I think I could talk about this outside, just talking about some of our freeze protection strategies. So I've already talked about, we already talked a little about our wind machines, burying plants or parts of plants with soil. Here in some areas of Ontario, starting to use geotextile materials. I mean, mulches have been used. And then in some cases, people are trying to use heat sources, sprinklers, more for frost protection. We're not using anything like that, but overhead sprinklers in parts of the world are being used, or a combination of methods. So that's just a typical wind machine that we have in our vineyards in Ontario. They're used for midwinter protection as well as frost protection. In some cases, when they haven't been vineyards with wind machines, people have utilized helicopters. This vineyard now has wind machines, but in this case, this was at 12 year, and this was Chardonnay, big block, massive block of Chardonnay. You probably know who that is. And they utilized, we have Niagara Falls nearby, and there's helicopter tours and what have you. And so people have tapped into, and there's also an airport right near there. So they've tapped into someone with a helicopter and they fly the vineyard and basically do the same thing that a wind machine does, where we have these radiation freezes. There's an inversion, as Kevin mentioned before, and basically mixing that warm air with the cold air below and cutting that inversion and the temperature inversion in half, basically. Now, the guy who really started a lot of wind machines in Ontario was Paul Boss Sr., who's at Chaudet Charms. And originally, this is what he was doing, was using helicopters. And then he found he's bought wind machines. And after one of our really cold winters, he had a crop and other people didn't. And that was enough for a farmer to say, these things work. Seeing is believing. And that's a lot of things, that's what we find a lot. You know, if you're a consultant or scientist or educator, extension, whatever, one thing I've learned, and I've learned this through Kevin and a lot of other people, is seeing is believing. You gotta, the growers, farmers, they need to touch and feel and see things to really believe in it. And if it's one thing to show them on paper, but it's really getting them out there and you getting out there and explaining things to them. And that's one thing that's really helped with the cold harvest research is they can see it. They can see it in their crops, they can see it in the health of the vines and so on. And that it didn't take much convincing, but then Kevin, Hugh Fraser, Helen, and some other people, Ken Slingerland from Omafra, and they did a lot of good research with wind machines and looking at how to use them properly and how they worked and efficiently in this. So they looked at wind speeds, they looked at all these different variables to see the range of wind machines, how their patterns were effective and so on. What were the effective patterns and going, you know, more and more on that type of thing. So we've got it pretty dialed down, I think, now in Ontario for using wind machines for frost. This is a grower in Niagara, and what they've done is they've covered after a good snowfall, they've covered the grafts and with they've gone through the V-plow and just kind of held up all the snow around the plants to help protect them. And so if everything was lost up top, the hope was to get some fruit from the bottom, or at least protect suckers on sensitive varieties. You know, what's the advantage of snow? What's the disadvantage of snow? Could someone figure out an advantage or disadvantage of?
It's a good insulation, but it melts.
Good insulation and it melts. And then knowing what you know about deacclimation, if it's warmer environment under that snow, you've now may have compromised the vine once the snow is gone. The other thing is warm tissue or brown, and later in the season, you've got brown wood, and that's gonna, from radiant heat, it's going to melt the snow, and you end up with little holes around the vines, little frost pockets. And so you can end up killing your trunks because the cold air just settles there and just, it's like putting your vines right in a freezer. And these are just examples of what's commonly done where we're covering vines, at least their grafts, with soil to protect the grafts. But this is actually in Prince Edward County where they've buried entire canes to overwinter the vinifera. We've already talked about vine alert.
What you said about the snow, it doesn't occur under the geotextile, like it's a better protection than the snow and.
For the geotextile, that's an extra level of protection, but you don't get as much.
There's not as much insulation.
There's not as much insulation. Yeah.
Because air can move through the geotextile, so you do have a cold air. You do still have movement, but when you get snow and it's packed, it's like this igloo. There's a critical, and it just stays there.
Yeah.
Okay.
So we've already touched on this, but one of our big programs that we've worked together on with Kevin, myself, and Ryan has been the Vine Alert program, which we talked about, where we monitor cold hardiness across Ontario. And it's really knowledge is power. If you have the technology, but you have to know when to use it and what's best to use it. And through the wind machine research and then having a combination of knowing what's happening within a dormant plant where you don't see anything. I mean, during the growing season, you could see what's happening with the plant because you've got all this active growth. You could say, oh yeah, my plant's under some stress. The leaves are warm, that type of thing. Dormant bud looks like a dormant bud from 90% of the dormant season. So the only way to know how hardy they are is to actually go and test them. And that's what we've done. And then we have a interactive website called Vine Alert, which has all that information for the grower community. We have over 300 growers that actively use the program. We've got people from Quebec that look at it and all other provinces as well. And overall, it's saved the industry millions of dollars, and that's on an annual basis, but reducing crop loss, and as well as increased management costs. Because it's a catch-22, and it's terrible, and this is why winter injury is so bad, is one, you get that direct loss after a bad event, and you don't have any crop, or have little crop, but then you have to manage the vines, do the same amount of work you had to do before pretty much, or more work, more hand labor and so on, by getting the vines back into production, or replanting and so on. So as what Kevin mentioned before, how the one person had 25% vine loss due to winter injury, and ended up costing them more money than if they would have just replanted it. And so these are the management costs can really build up, but you don't have the income coming in because of loss of fruit. And so that's where this program has really helped us, and why our industry has invested in wind machines and so on. Because it's helped create a more sustainable industry. So this is just an example of what the website looks like. There's the link. It's available to anybody so you can see what we do. We've got our bud hardness information. We post our bud survival information. We have some resources as well. And we cover all the main growing regions of Ontario right now and look at over 9 varieties. And this is just a typical example of what a grower can see. We display the information in multiple formats because some people like to see a table, some people like to look at the graphs. We've got comparison options so you can see different varieties or how a variety compares at different locations. Let's say if you're a grower and you have you're growing multiple varieties and multiple sub-appellations, for example. And then we have our minimum temperature data and our hardiness data. And we express it in LT 10, 50, and 90. So we're looking at different levels of risk. So generally speaking, for wind machine use, they'll use that LT 10 value. So that's when they're first going to see damage. And LT 10, 50, and 90 the variability between the three can differ throughout the different times of the year. Like during acclimation or deacclimation, the LT 10 value could be a lot different than the 50 or 90. But then there's sometimes where again, during deacclimation, for example, those values get really tight together. And the tighter the 10 and 50 are together, the more risk you have, because you get even close to that 10 value, you can get a lot of damage because they're not too far between. But in early deacclimation, for example, there'll be 10% of the buds, let's say, that are deacclimating at a faster rate, and that's reflective in the data. And that just goes, just like how the vines acclimate from base to tip. And then the same thing when they deacclimate, you're going to get earlier bud break on the canes or the buds at the end of the cane or shoot.
The bud hardiness, is it the entire bud, or do you concentrate on the primary bud?
Oh, good question. Yeah, when we get the buds, when we do the hardiness, it's based on primary buds, but we don't know for sure that they actually are the primary bud that we're that we're getting the peak from with our data.
We've been able to pick out though, it's because it's based on a electrical impulse when freeze occurs, and we're pretty sure, that it's the primary bud that we're measuring, because we can get small little spikes in association with. We actually get a very early one for external water that will freeze, and then we'll actually get our true spike. We put 5 buds per cell, and there's 9 cells per tray. So we're dealing from 45 buds that we're actually looking at to try and come up with this data, rather than just 1 or 2 or 3. And it's always a single variety on a single tray, so that we're just trying to increase our numbers to keep our reliability feeling in what we're doing. But the bulk of it's primary bud, we feel it's primary bud damage.
But when you examine the bud just by hand,
For survival.
yeah, do you think it's possible to have a dead secondary bud and a live primary bud?
Yeah. We
It
see
is?
that.
But usually, I feel like we see more, I mean, at least in the data I've looked at, it's mostly the primary bud that is dead, and then the 2 other ones are...
Yeah, that's generally how it works, but you can have a dead primary and
You
a
can have
live
a-
secondary.
Yeah, the bulk of the time though, it's your primary bud will die before your secondary bud.
Yeah.
And
Yeah.
The plant, it's a basic plant survival. That's,
Yeah, yeah,
that's
yeah.
what I'm adding in. Because it's location, water, size, everything else comes into play.
Yeah, that's what I'm asking. Is
But
it
the key-
possible to?
It's possible, but the key is doing,
It's
we
usually
do
not-
thousands and thousands and thousands
Yeah, yeah,
of bud cuts every winter, and the data we report is always primary bud.
Yeah, we always report primary, and then the odd time if it's really bad, we will sometimes have report secondary buds. But yeah, this data is based on primary bud survival or primary bud hardiness and
And
survival.
yeah.
If we've got 50% primary bud survival death,
Yeah,
we're gonna have secondary bud death, and we're gonna
Yeah.
have wood injury.
Yeah, yeah, yeah.
yeah.
Like it's-
Okay.
That's how it goes. And then the other thing is when we have an event like this right here, where the minimum temperatures cross, especially if it goes below -50, we go out and sample immediately after that event, because it could be followed by another one, and we want to see when that damage may have occurred. And our hardening, one thing Kevin and I are really proud of is that this data, it matches. If we hit LT50, we generally see 50% bud survival when we do our cuttings, primary bud survival, or bud loss, whichever way you want to look at it. And so it's been a very good predictor of injury, and then we follow up with that though, just to validate how much injury has occurred. And then we're learning a lot about different events and how different cold events can be, ones that we thought might be more damaging weren't, and other ones were. And the polar vortex year was just insane how many events we had. But it's been a good learning tool for us as well as the growers. But what we found with geotextiles is that they basically, a lot of times they're almost cutting the temperatures in half in terms of our minimum temperatures that we're seeing. This work was done in Prince Edward County, and when in January had temperatures -22, under the materials was -12, and same thing in this case, -33 and about -15. And then the other thing we found is that they're basically doubling the yields, and in most cases, and not impacting shoot numbers. So we're basically having a lot of blind shoots with buried vines, and then having better crop levels with the geotextile. And this was using 2 different types of geotextile, different timings of removal, and just had more consistent bud break, even bud break, and compared to a buried vine. And just overall, just better health. I mean, this cane had lots of damage where the soil washed off. And, it doesn't look as nice compared to this one here. And I'll just stop there. I just have some interesting data just showing how trends are changing in Europe and how frost has become more of an issue, and is talking about that. So anyways, let's go outside.